Hello guys, welcome to Gate Academy Global. So, am I audible to everyone? Am I audible to everyone? Just give me a thumbs up for if I am audible to everyone, if I am visible to everyone. Just do let me know, but just drop a text here. Am I audible? Fine. So, what we have seen till now? Till now we have seen the stopping side distance, like how we can calculate the stopping side distance. How we can calculate the stopping side distance. This is what we have seen till now. Stopping side distance. We are talking about the important topic of gate examination. This is side distance consideration. That is side distance consideration, and in side distance consideration we would like to talk about, because most of the question were asked from side distance consideration. So my main motive is to first to tell you like how we calculate, to focus more on that topic which carry larger weightage or greater weightage in gate examination. Fine. So till now we have seen stopping like side distance consideration, and in side distance consideration we have seen how we will calculate SSD or stopping side distance. But what we have seen in SSD till now, we have seen that how SSD can be found on flat gradient. In last lecture, I have derived the expression for finding stopping side distance on flat gradient. Now, what our next topic for today is we are seeing the effect of gradient on stopping side distance. So let's see how the gradient is going to affect our stopping side distance. Let's discuss about this first. Fine. So first thing that I want to tell you about is this: what is up gradient and what is down gradient. Because while going on a gradient, we should know what, like if in a question they will tell you that you are moving on an up gradient, and if they will tell you you are going on a down gradient, then you should be very much sure about it. What is up gradient, what is down gradient, how we calculate the gradient value, how we actually calculate the gradient value. So let's see here. What is up gradient? Whenever your horizontal angle, whenever you get a positive angle from horizontal, you'll say this is your up gradient. Or we can say your rise by run should be increasing. Fine. So this is what up gradient is. And if we talk about down gradient, this is what your down gradient is. Your angle is decreasing as you move ahead. And here your angle is increasing as you move ahead. Fine. So the up gradient and down gradient can be defined like this. Like as you go further, as you go ahead, you will find an increasing angle. This is what up gradient is. And if you go ahead, you will find you will find there is a decrease in value. So you can say this is what down gradient. This is what down gradient is. Fine. So this is what down gradient. So this is the basic that we seen, like what is up gradient and what is down gradient. So now let's see how we can find the, like what will be the effect of up gradient or what will be the effect of down gradient on our stopping side distance. So let's see here what is the effect. So let's see here what we are seeing. We are taking the case that we are moving on a up gradient. Like our vehicle is moving on a up gradient, and then we see how this up gradient, movement of our vehicle on a up gradient, will affect the stopping side distance. Consider this as this is your angle theta. This is your road or the pavement on which our vehicle is moving. This is your road or pavement on which our vehicle is moving. Fine. Let's see. This is your vehicle that is moving on a up gradient. And it is having some velocity, design velocity small v. Now what is happening after seeing an object, the driver, or you can say you are the driver, you will apply the brake. Hello everyone, hello Vijay, hello Suraj. So what we'll see that if you are moving in this vehicle and you suddenly applies the brake, What will happen after seeing an object? You see, you are moving with a design velocity v, and after seeing an object, you just applied the brake. So what will happen? Your velocity will change from v to 0. So the next position of your vehicle will be somewhat like this. Somewhat like this. You are here, and the velocity of your vehicle is 0. Let's see here. Consider it as a first position and it is as second position. So the distance what we need to find is this distance, and it is termed as braking distance. We are talking about this braking distance. Now some of you might get confused, sir, why we are calculating only braking distance, why we are not considering here lag distance. So the reason behind it, why we are not considering the lag distance and why we are only taking the braking distance in our consideration, the point is because if you see lag distance, the value of, or the expression for the lag distance, you'll see the expression for lag distance is v multiplied by t. Here v is the velocity, and t is the time, reaction time. So if we see about the lag distance, then in lag distance there is no term that is going to be affected by the gradient. So we are not considering lag distance because we can see that your lag distance is not going to affect, it won't change even if you are moving on a down gradient or if you are moving on a up gradient. That's why we are not considering lag distance here. Whatever the change you will see only in the braking distance. So we'll calculate the braking distance only, and then after that we will calculate the final SSD just by adding the lag distance in the particular value that you are getting from this expression. Fine, that you are getting from this particular expression. So let's see what I am doing. Thank you, Akshay. Thank you so much. So let's see what I'm doing here. This is your braking distance. L is your braking distance. Now we'll write the equation, or we'll see how the expression can be derived. Fine. So what is happening here? Here on situation number 1, your velocity of your vehicle is design velocity, that is v. And then in second position, the velocity of your vehicle is 0. Fine, the velocity of your vehicle is 0. So what is happening here? The whole kinetic energy, what we are applying here, will apply the work energy principle, and you'll see your whole kinetic energy is converting into work done. And the value and the coefficient of friction given here, and the coefficient of friction for this particular pavement is given as F. If somebody talk about the frictional force that is acting, on this pavement, it can be given as, so let's see, first what I'll do, I'll break the forces here. I'll write the forces here for you, like what are the type of forces and what kind of forces, what are their nature, we will see here. Okay, let's see. This is if we talk about the weight, this is the component of weight. This is the component of weight. Fine. If we talk about the axis that is perpendicular to that lane, and axis parallel to the lane. Fine. Now what I'll do, I'll just take the component of this weight. Here, perpendicular to the surface. So the component, if this angle is theta, so this component we can say it is equal to W cos theta. Fine. And if we take the component in parallel to the surface, we can say this, it is equal to W sin theta. Fine. If we talk about the normal reaction, you can say, this normal reaction, this is your normal reaction, and this normal reaction is equal to W cos theta. Fine. So if somebody asks you what will be the normal reaction for this particular vehicle, so you can say the normal reaction, will see the whole total vertical force that is acting downward will be the normal reaction. So the total vertical force that is acting downward is W cos theta. So we can say that the normal reaction is W cos theta. Fine. So your normal reaction will be W cos theta. Fine. If somebody asks you what will be the frictional force, the coefficient of friction is F for the particular pavement, and coefficient of frictional force can be written as capital F. and frictional force can be written as capital F. And frictional force can be written as capital F. Fine. So this is your frictional force. This is your frictional force. That can be written as capital F. What will be the value of this capital F? So you can write this. The value of frictional force is coefficient of friction multiplied by normal reaction. Coefficient of friction multiplied by normal reaction. So you can say that the value of frictional force will be equal to coefficient of friction multiplied by normal reaction. And normal reaction is W cos theta. W cos theta. Fine. Now what we'll see what are the forces, like what are the forces that is trying to stop our vehicle. What are the forces that is trying to stop our vehicle by applying the energy conservation rule here. Let's see how we can find it. So what we are doing, but I can't speak in Hindi over here because this channel is named as GATE Academy Global and it is only for those students who are willing to learn this subject in English. So if you want to see lectures of mine in Hindi, you can visit our channel GATE Academy main channel, where I'll give lectures in Hindi only, and this is the channel which is totally dedicated for those students who are willing to learn the subject in English. Fine. So this is the only reason I am doing all this in English. Fine. I'm so sorry for it, but like if you want to go through these lectures in Hindi, you can go over there and see. Fine. There are also some lectures available in Hindi and for transportation engineering. You can watch them. Fine. So what we are doing here, let's see what we are doing here. We are applying the work energy principle. We are applying the work energy principle. Work energy principle here. We are applying the work energy principle here. We are applying the work energy principle here. What I'm doing in this work energy principle, all of your kinetic energy, or we can say the change in kinetic energy is equal to work done. The change in kinetic energy is equal to work done. The change in kinetic energy is equal to work done. Fine. So what will be the change in kinetic energy here? Just have a look about it. Just have a look to it. Here at your position number 1, the kinetic energy will be half mv square. At position number 1, your kinetic energy will be half mv square. And for position number 2, your kinetic energy will be 0 because velocity is 0. So we can say this half mv square. Change in kinetic energy is equal to half mv. What is the work done here? All the forces that is trying to stop the vehicle, multiplied by the total length that is taken by the vehicle to come to dead stop position. So all the forces that is trying to stop your vehicle is, the first force that is trying to stop your vehicle is W sin theta, the component of weight that is acting in downward direction. And if your vehicle wants to move in further ahead in up gradient, but this is the component of weight that is trying to stop your vehicle. Fine. And what is the another force that is trying to stop your vehicle is this frictional force, because the friction is always trying to act opposite to the direction of motion, So there are only two forces, that is trying to stop your vehicle from moving is the component of weight and the component of force, like frictional force. So we can write it in a combined form. And the combined form will be, it is F multiplied by W cos theta, this is your frictional force, plus W sin theta, this is the component of weight, multiplied by capital L. Fine. Is this clear to everyone? Just drop me a text like, if this equation is clear, we'll solve it further. Is this equation is clear to everyone, like whoever watching? Just drop me a text whether it is clear to you or not. I just want to know whether it is clear to you or not. Just let me know whether it is clear or not. Fine. Sanjay Rawat. Okay, Abhinav. So it is clear. It is clear for everyone. Fine. So let's see here. What we'll do? It is a half mv square is equal to Fw cos theta plus W sin theta. Now what we'll do? We'll solve it. Fine. So see here, it is half mv square is equal to W. Just take W common from this particular equation. We'll see it is F cos theta f cos theta plus sine theta. It is f cos theta plus sine theta multiplied by L. Okay, fine. If it is clear, just fine. I have one request to all of you guys. Just share this lecture with all of your friends who are not very much comfortable in Hindi and who are willing to learn new concept in English. Fine. This is the reason why we... can we do this by applying law of motion? No, we can't do this by applying law of motion. This can't be derived by using the law of motion. Thank you so much, sir. I just want to thank you for giving us a chance to take lectures on Gate Academy Global channel. Thank you so much, Sake sir, for this. We'll write it as half mv square. This w can be written as m mass multiplied by g, mg, fine. And next is f cos theta plus sine theta multiplied by L. Fine. Now what we'll do, we'll cancel mass with mass. So here our next expression is L. We just want to calculate L, that is breaking distance. So this expression can be written as it is v square divided by 2g, it is f cos theta plus sine theta. Fine. So what we'll see here, this is your breaking distance, this is your breaking distance. But this can't be used this can't be used in your equation just to get the answer. This expression can't be used because this is not the final expression what we are willing to find. Because we want our expression that should be in tan theta. So we can use that expression directly to get the breaking distance. So what we'll do, normal reaction का value w cos theta कैसे? ठीक है. See here normal reaction, how normal reaction is w cos theta. See here how normal reaction can be taken as w cos theta. See here, there is a only vertical force. If I just show it to you in a zoomed form, in a zoomed version, you can see here what is exactly happening here. Just see here. Consider it as your flat gradient. Consider your vehicle is moving on a flat gradient. Fine. Consider your vehicle is moving on a flat gradient. What I'm doing, I'm just showing it a zoomed version of this. Thank you so much, sir. What I'm doing here, considering I'm giving you the zoomed version of whatever happening with this car. Fine. This is your car on which we are moving. Fine. So if we talk about the weight of this particular car, it is w cos theta. This is given here, w cos theta. Now we'll ask, like, what will be the total reaction? Feel by this car? What will be the total force will be feel by this car? So if the total weight or the total force in downward direction is w cos theta, then there is always an equal and opposite reaction. You might have heard about it. There is always an equal and opposite reaction. So the equal and opposite reaction for this w cos theta is normal reaction. That's why it is written as normal reaction as w cos theta. Normal reaction, why it is called as normal reaction? But it's because it is perpendicular to the surface. If we talk about the horizontal surface, it is written as w cos theta. If we talk about the perpendicular surface, it is written as w cos theta. Fine. So this is the reason why it is written as w cos theta. Fine, this is the reason. So now let's go to the final result or final conclusion. What we'll do here, we'll take theta very small. We'll take an assumption. We will take theta very small for this particular equation. Why we are taking theta very small? Because if you go through the table that is given for rolling plane and rolling terrain, you'll see that the value of theta is very much like for hilly terrain. The the maximum value is given for hilly terrain, and it is given as 60%. So 60% you can say it is it is 0.6. So the tan theta value is 0.6. So it is quite less than. So the value of theta is taken very less for this particular terms, for this particular questions. Fine. So the gradient will be very much less. So the value for theta, or it can be written as considering theta very small, considering theta very small, so it can be written as, currently the equation is L, it is V square divided by 2G L, V square divided by 2G F cos theta plus sin theta. F cos theta plus sin theta. This is the equation we wrote here. F cos theta plus sin theta. Fine. So now what we'll do, if we take theta very small, then what will happen? Just have a look over here. What will happen if we take theta very small? Then this is your angle, and we are taking theta as very small. So you can say that this is your base, this is your hypotenuse, and this is your perpendicular value. Fine, this is your perpendicular value. Now what will happen? Your base value, will approximately equal to hypotenuse, because this theta is very small. So you can write it as your base as your hypotenuse value. Fine. And if you can write this base as hypotenuse value, now you know that your sin theta value equal to P by H, and this H can be written as B. So this expression can also be written as P by B. Fine. Now if we talk about the cos theta value, you know that this value is B by H. So this B can be written as H. So you are writing this expression as H by H, or you can say 1. Now you can say that tan theta value, if you talk about tan theta value, you know that this value is tan theta is equal to P by B. And if this value is written as P by B, this is also written as P by B. So you can write it as, that sin theta can be written as tan theta if theta value is very small. If theta value is very small, you can write sin theta as tan theta. Fine. So what will happen? If we see this object, if we see this expression, this expression can be written as L is equal to V square divided by 2G. Now the next expression, next thing, F cos theta. So this cos theta can be written as 1. Because theta is very small. So this cos theta value will become 1. So this expression can be written as F plus, and sin theta can be written as tan theta, So the final expression is written as somewhat like this. So the final expression can be written somewhat like this. This V square, L is equal to V square divided by 2G F plus tan theta. Fine. And this tan theta is representing your gradient. For using it as for some calculation purposes or for questions, you can write this expression as L V square divided by 2G F plus G%, and this G% is representing your gradient, Why I am taking it as G%? Because it is representing gradient, and tan theta is also representing gradient, but finding the value from G% is quite easier than comparative to tan theta value. Fine. So this will make your expression quite familiar with you. This is the reason why we are using the G% value here. Fine. So this is the reason why we are taking it as L. Fine. If somebody asks you what will be the stopping side distance, for up gradient, so you can say that the stopping side distance for up gradient, is equal to lag distance plus braking distance. So the lag distance plus braking distance value will be equal to VT, because I already told you before this whole thing, I already told you that lag distance won't get changed because of gradient. Whether you are moving on a down gradient, whether you are moving on an up gradient, this won't going to be changed. Fine. So this value will be VT plus V square divided by 2G F plus G%. This is your final expression if you want to calculate the stopping side distance. For your vehicle that is moving on up gradient. This is your final expression for stopping side distance that your vehicle that is moving on your up gradient. Fine. Is it clear to everyone? Just do let me know. Is it clear to everyone? Is this clear to everyone? Like how to get the expression for stopping side distance, how to calculate the expression for stopping side distance. Is this clear for everyone? Yes, fine. Now we will see how this same thing is happening for if you are moving on a down gradient. What is happening if you are moving on a down gradient? What will be the change in your expression when you are moving on a down gradient? So let's see here how we'll calculate, or how we'll see what will happen if you are moving on a down gradient. So let's see what will happen if you are moving on a down gradient. If you are moving on a down gradient, what will happen? So let's see here what will happen if you are moving on a down gradient. Let's see here what will happen if you are moving on a down gradient. Consider this as your lane. Consider this as your lane. This is the lane on which you are moving on down gradient. This is the down gradient. Tan theta is the value for angle. The value angle is tan theta. Fine. Now what is happening? This is your vehicle. This is your vehicle. This is your vehicle, and you are moving on a down gradient. Here the value, it is the first value, it is velocity is given as v. This is your first value, this is your first value, and you are moving on a down gradient. Fine. So what is happening? The moment you seize an object, you applied the brake. The moment you seize an object, you applied the brake, and what will happen? This is what happening here. This is what happening here. The velocity will become 0. The velocity will become 0. What we need to calculate, we just need to calculate the braking distance in between these two positions. What we need to calculate, we just need to calculate the braking distance between these two positions, and we can calculate it very easily. We can calculate it very easily because we know that how we calculated the up gradient. We are quite सोम का लाइव क्लास आप गेट अकेडमी का चैनल फॉलो कर लो एंड विल कम टू नो कि कब होता है. ठीक है, आपको नोटिफिकेशन आ जाएगा बोला. ठीक है. सो व्हाट इज हैपनिंग हियर, लेट्स सी हियर व्हाट इज हैपनिंग. Let's see here what is happening. What we are doing, we are applying, like first I'll divide the forces for you. I'll divide the forces for you. So the forces is somewhat like this is the weight acting on this vehicle. This is the weight acting on this vehicle in downward direction. This is the weight of the vehicle that is acting in downward direction. The component for weight is given as W cos theta here. The component is given as W cos theta, weight component of weight. Here the component of weight along the surface is given as W sin theta. Here component of weight is given as W sin theta. Fine. And if we talk about the friction, value of friction, somebody has now if W, this is the frictional force. This is what it is, frictional force. Now what we'll do, we'll calculate, like we'll do again we'll apply the energy conservation here. Again, problem. Is there any else? Is there any audio problem to anyone else? Like anybody? Like am I audible to everyone? Not audible. Is it written? Now clear, fine. Now clear? Fine. So let's start here. What we'll do, we'll again apply the energy conservation here. Energy conservation here. And what will happen if we apply the energy conservation? You can see here that change in kinetic energy, will be equal to work done. Change in kinetic energy is equal to work done. Now we'll see, this is your first position and this is your second position. If you apply the if you apply the kinetic energy conservation here, so the velocity, we can say the kinetic energy for this particular position number 1 is half mv square, And if we talk about the kinetic energy for this second position it is written as 0. It is written as 0 because the velocity is 0. Fine. Now if we talk about the work done, the value of work done. So what we are saying, the work done value for work done is the total force that is trying to stop your vehicle. So here your frictional force is acting opposite to the direction of motion. Your frictional force is acting opposite to the direction of motion. So we can take it as your it is just opposing your vehicle to move further. But here the value for W sin theta is trying to push your vehicle ahead, So finally if we talk about the resultant of this forces, you can write it as FW cos theta minus W sin theta. This is the force that is trying to stop your vehicle. This is the force, combined force that is trying to stop your vehicle. So this can be written here, It is FW cos theta minus W sin theta, whole multiplied by L. Now we'll solve it further. We'll solve it further. What will happen? Now, let's see what will happen. So it can be written as half mv square is equal to W, we'll take the W common, can be written as F cos theta minus sin theta multiplied by L. What will happen? This W can be written as mg and m and m can be cancelled out. So the equation can be written as G F cos theta minus sin theta multiplied by L. We need to calculate the value for L. So what will happen here? Let's see what will happen here. This can be written as V square divided by 2G F cos theta, minus sin theta. 2G F cos theta minus sin theta. Fine. If we take theta very small, if we take the value of theta very small, this expression can be written as L equal to V square divided by 2G F cos theta can be value 1, can be written as 1 minus sin theta, and sin theta can be written as tan theta. This is the expression for down gradient. But you don't need to memorize whether the value is plus for up gradient or whether the value of whenever a vehicle is moving on a up gradient, so the value will be plus, and when our vehicle is moving on a down gradient, the value will be minus. It can't be remembered like this because you can't memorize it for a long time if you just remember by sign conventional, because in examination there is a peer pressure over you, and you'll surely, there is a probability, almost 90% probability, that you will get confused whether I need to take positive sign or whether I need to take negative sign when you are going through a hard question or when you're going through a tough question. So it is quite I know each and every student is not quite comfortable while studying, while going through a particular tough question. Fine. So what we'll do, I'll give you a method, or I'll give you a common sense to learn, to memorize. How can you remember the terms? How can you remember the term for this particular expression? So let's see here how we can calculate. How we can remember the particular term for this up gradient and down gradient. Fine. So just have a look at it. Just do let me know first, is this clear to everyone? Whoever is watching, is this clear to everyone? Then we'll see how we can remember the particular term for a up gradient and a down gradient, and how it is affecting, while increasing the speed, while increasing the braking efficiency, while increasing the gradient, what is happening to the particular term. We'll see the expression, how it is affecting. So is it clear to everyone? Yes. Fine. If it is clear to everyone, let's see here how we can memorize it. Fine. How we can memorize it. Just have a look at here. Fine. So how we can remember? Just see here. I'm just writing the term L. I'm just writing the term for braking distance. I'm not taking here lag distance, because the whole game is for braking distance only. Fine. So we can write it as that L can be written as V square divided by 2G F plus minus tan theta. f plus minus tan theta. Fine. This is the way you can write this. This is the way you can write this. Fine. Here the v can be written as v. The unit for v is in meter per second. The unit for v is written in meter per second. Fine. The unit for v is in meter per second. Now see here. Some of you might can remember this just by going through, like if you have a good memory, you can remember it by just that plus is for up gradient. Whenever your vehicle is moving on a up gradient, you can use the plus in this particular equation, and minus is for down gradient, and minus is for down gradient. Fine. But how I remember this particular thing, let's see here. If we talk about the normal flat gradient, what is happening here? We will, like, I just apply the normal common sense here and I'll just remember it. Fine. So let's see here how I remember this particular term. So for flat gradient, this value can be written as v square, L is equal to v square divided by 2gf. L is equal to v square divided by 2gf. Now if we talk about up gradient, you know that your common sense till now, because this expression, you learned this expression today itself, but till now, fine, but till now what is happening, this expression, thank you Ashish, but this expression tells us, like, from our common sense, we have observed till now that if you are going, or if you are moving on an up gradient, and you apply the brake, you stop early before, like, in comparative if you are moving on a flat gradient, in comparative to if you are moving on a flat gradient. This is the reason behind it. So you can remember this just by one thought, that just by common sense, that if you are going on an up gradient, you need a lesser distance comparative to if you are moving on a flat gradient. Now how things are happening, let's see here. This is the expression for up gradient. This is the expression when you are moving on up gradient. This is v square divided by 2g f plus tan theta. Fine. So what is the difference between this? And why this L is coming less for up gradient and this L is coming more in comparative to up gradient? Let's see here. What is happening here? We are adding a term to the denominator. Let's assume something. The numerator value for both the cases is given as 10. Numerator value is coming out as 10. Fine. Let's take an example. The numerator value is coming out 10 and the denominator value for 2g and f is coming out to be 5. Fine. But what we are doing here, we are adding an extra term. Let's say tan theta given value is 1. So what we are doing here, we are adding an extra term. In our denominator. Now this value won't be 5. This value will be 6. Now what will happen? This value will be 6. So what we are doing here, if you see this expression L will come out to be 2. But if you see this expression here as per the example, you can see it is 10 by 6 or 5 by 3, and 5 by 3 is somewhat less than 2. This L will be less than 2. So you can see here your expression for L will be less if you are moving on an up gradient in comparison to if you are moving on a flat gradient. Similarly, you can also remember this up gradient. After up gradient, you can see this for down gradient. Let's remember it for down gradient. What is happening in down gradient? This expression in down gradient can be written as v square divided by 2g f minus tan theta. Now what we are doing here, you are just subtracting a term from the expression. This expression, and your common sense says it, and your common sense, good afternoon Suresh. So, and your common sense says that, if you are moving on a down gradient, you'll surely take more distance comparative to if you are moving on a flat gradient. So why this distance come out to be more in comparison while you are moving on a flat gradient? See here how we are, like, why we are getting a more distance, why we are getting more braking distance. Fine. So what we are take an example again, the same example. This v square value is coming out to be 10 and the 2gf value is coming out 5. 2gf value is coming out 5. But you are subtracting a term from the denominator. What we are doing, we are subtracting a term from the denominator. Let's consider this tan theta value as 1. So what we are doing, we are just subtracted the term from this whole 2gf value. So you'll get the value here 4. And if you are getting this value as 4, so this can be written as 10 by 4, 5 by 2, or it is 2.5. So this value is L is 2.5. So if they ask you which of the out of these three terms, which will give you the maximum braking distance, so you can write it as down gradient will give maximum distance in comparison to up gradient and flat gradient. If an examiner wants you to arrange this in descending order, so you can write it as this descending order. This is the descending order for the braking distance. Your down gradient will be the maximum distance. Sorry, this won't be the order. Your order will be somewhat like it is down gradient first, value for down gradient, then the value for flat gradient, and after that the value for up gradient. This is somewhat I want to explain. Like this kind of question like till now this kind of question is never asked, but this is the way like they can ask a good question. Like if I just want you to compare the flat gradient with up gradient and a down gradient, you should be very much comfortable to compare all these situations. Fine. This is the type of question which I can expect in some of the examination, might be in JEE, might be in AE, or might be in GATE, because this is the concept like everyone should be aware about. Fine. So is it clear to everyone? Like I think it is quite clear to everyone, like the way we can compare these three things and how this expression can be remembered, that the denominator is getting lower just by subtracting a thing. So the whole side distance, braking distance is increasing. This denominator is in positive, like something is going to add in this particular denominator. So the whole thing is going to be decrease. Fine. Is this clear to everyone? Fine. So this is the way you will calculate the stopping side distance. Fine. Stopping side distance on up gradient. And thank you so much, Manish. So this is the way you can see how we calculate, like how we see the expression for how we'll derive the expression for up gradient and down gradient, and how we can memorize it. Fine. Now I'll see the next topic. Next topic is your overtaking side distance. So let's see here how this overtaking side distance is being, or we can do a question here, or we can do a problem here. Like let's solve a problem first. Let's solve a problem first here. Calculate the minimum side distance. Let's solve a problem first here on up gradient and down gradient, or we can say it is a good problem. Like nobody is like most of the people don't know about the concept behind the particular problem which I am going to discuss. Fine. So it is some of the best problem that I usually try to that my students should go through such problems. Fine. So this is one of my classroom program problem. So you can, like, I'm just giving you an idea like how we deal with such kind of problem in our classroom program. Fine. So let's see here. Calculate minimum side distance. It is calculate minimum side distance. Calculate minimum side distance to avoid. Just try to do it by yourself. I think this it can be done very easily. But you need to focus more about the thought of giving some another chance to buy some another method. Fine. I'll tell you some different method for it, and you'll it will be clear for you like why we can't use a relative velocity concept here. Okay, fine. So I'm just giving a thought. Just try to think about this problem through relative velocity concept, and just give it a thought why you can't do it just by using the relative velocity thought. Fine. So let's write it here. Calculate the minimum side distance. Calculate the minimum side distance to avoid head-on collision. To avoid head-on collision. Head-on collision. Head-on collision. Head-on collision of two cars approaching from opposite direction. Approaching from opposite direction. Fine. Approaching from opposite direction at a speed of 90 kmph and 60 kmph respectively. Fine. And the friction value F is given as 0.35. The value for friction is given as 0.35. Fine. And the coefficient of friction is given as 0.35. And reaction time of the driver is given as 2.5 seconds. 2.5 seconds. I just need an answer for it. What will be the minimum side distance? Is required to avoid the head-on collision between the two vehicles that is coming from opposite direction to each other. Fine, that is coming to opposite direction to each other. What will happen? So I'm just giving you a brief idea. Just try by yourself. And I think this is a simple problem, but I just want you to know why we can't use the relative velocity concept here. So this is the your vehicle number 1. Your vehicle number 1 coming with a velocity V1, coming with a velocity capital V1, that is 90 kmph. And we know that this is a single lane problem. This is your single lane problem. So in the same lane, your another vehicle is coming from the same lane, because it just said us, the question didn't tell about the number of lanes or the number of ways. Like whether it is a two-lane traffic, whether it is a single lane two-way traffic, whether it is a single lane one-way traffic. But the word head-on collision itself expressed that it is a single lane two-way problem. Fine. So the expression for this is, it is the velocity given here is 60 kmph. Now what we need to do, we just need to calculate the stopping side distance for this particular vehicle, so we can avoid the head-on collision. Here. What we do to avoid the head-on collision? I just want to give you a thought, like why you can't think about the relative velocity concept. Just try to do it by relative velocity concept, because I know that the answer is coming. Some of students, some of you might think about it. Why it is not coming? Why it is not coming right answer? Why the right answer can't be get by relative velocity concept? Fine. So I just want to that you to solve this particular question and give me the answer. Like what will be the correct answer for this particular problem. And those who are new here, you can join my Telegram group for the updates, like whatever the updates you want, whether like what will the class timing, what will be the subject, what will be the topic, and you can discuss your doubts over there also. Fine. So you can join my Telegram group through this particular link. You are like you can see the particular link in your comment box. Fine. So you can join my Telegram group through this. And all those students who are new here, you can subscribe the channel and you'll get the videos on a regular basis here. You can get the videos in regular basis. So you can you can polish your thoughts, you can polish your concept here. Just by going through the videos here. Fine. Is anybody getting some answer for it? Any of you? Getting answer for it? It is a good problem. I think it is a good problem. Like until and unless you know the concept, it is a good problem. And if you don't know the concept, it is just a theoretical problem. You can solve it just by applying the formula. It is a very easy problem just by applying the formula. You can solve it You can solve it. I'm just giving you a time. 153.651. Yeah, Abhinav, this is the value for SSD 1 only. This is not the final value. This is not the final value. Okay, let me do it for you. Okay, let me do it for you. I'll do it for you. Just have a look. Have a look. I'll do it for you. Just have a look here. Just be with me. Just be with me, because this problem, I'm going to explain some different level concept here, and I just want you to be with me here. Fine. Just don't put just don't comment. Just don't write anything. Don't try to solve it, because I have given you the enough time to solve it by yourself. And I think that whatever the concept I'm going to tell you, it is quite something different from all the concept that I told you till now. Fine. So this is the reason why I just want you to keep calm and just put your pen down. Put your pen down and just look at it here. Look at it here. Fine. Let's see how we are going to solve this particular problem. Let's see. This is the lane on which we are talking about, on which our vehicle is moving. This is the lane on which our vehicle is moving. This is the lane. This is the velocity. The velocity v1 is given as 90 kmph. Is given as 90 kmph. Fine. This is your second vehicle. This is our second vehicle coming from this particular direction, and the velocity for this is v is equal to 60 kmph. V2 is equal to 60 kmph. Now what I told you, I told you if they talk about, there are some particular cases for calculating the SSD. Let's see those cases first. The case one is, your case one says that for case of stopping side distance, that first case is if your vehicle is moving on a single lane, one-way traffic. If your vehicle moving on a single lane, one-way traffic, then what will happen? If your vehicle is moving on a single lane, one-way traffic, then what is happening? What you can see this is your single lane. This is your single lane, and on this your vehicle is moving, and on this your vehicle is moving. This is your vehicle that is moving on this particular track. Now what is happening? There is no particular thing here, or no particular object here. The only thing that comes here is some pseudo element or pseudo object, or we can say some object here. But this particular vehicle can't see any next vehicle that is coming from the opposite direction. Fine. So after seeing this particular object, this driver applies the brake and will take SSD, minimum SSD distance, that is stopping side distance, to stop its particular vehicle. Fine. Now if we talk about the case 2, the second case says that if you are moving on a single lane, two-way traffic, if you are moving on a single lane, two-way traffic, what will happen? If you are moving on a single lane, two-way traffic, then what will happen? Let's see here. This is your lane, on which your vehicle is moving, but here now the traffic is two-way traffic. So vehicle will come from both the directions. So this is the velocity we are considering the case when the velocity is same for both the vehicle. Fine. Velocity is same for both the vehicle. So what will happen? Your vehicle, this is your vehicle, and these are the two vehicles coming from opposite direction to each other, and the velocity for this particular vehicle is given as v. So they will take this vehicle will take SSD distance from here to stop, and this vehicle also take SSD distance from here to stop. If somebody asks you what will be the total distance required to stop the vehicle or to avoid the collision, so this total distance will be equal to twice of SSD. Fine. So this is the way you can calculate the distance. So this is the case what we are doing here, but now we are taking the velocity as different. So we can say, now we'll take the this is your A part for this second term. Now we'll talk about the B part. What will be the B part? B part, your velocity is different. Velocity is different for single lane two-way traffic. Now what is happening here? Let's see what is happening here. This is your lane, single lane. This is your single lane. In this single lane, your vehicle is moving in this direction. With velocity v1, and another vehicle is coming from the opposite direction with velocity v2. Now they will take some different velocities, some different distance. So we can say this is the distance SSD1. and this is the distance known as SSD2. This is the distance known as SSD2. So the combined, if somebody asks you what will be the combined distance, what will be the combined distance to stop the vehicle just before the collision or to avoid the collision or to avoid the head-on collision, this total distance will be equal to SSD1 plus SSD2. This total distance will be equal to SSD1 plus SSD2. Fine. Just do let me know whether it is clear to you or not, because we are going to use this particular concept here. And before that, I just want you to have a good idea regarding these two cases. So that's why I just told you, I come to a conclusion that I'll explain this particular concept in this particular question. Fine. Just do let me know whether it is clear to everyone, like everyone who is watching, it is clear to you. Fine. If it is clear to you, now let's see what will happen. What will happen? This is the total distance you can calculate, that is SSD1 plus SSD2 for a single lane two-way traffic. Now let's see what will happen to your vehicle and how you will calculate the particular distance for this. Fine. Let's see here. This is your vehicle. Moving with velocity V1. And this is your vehicle moving with velocity V2. This is your vehicle moving with velocity V2. Fine. Now if V1 is written as 60 kmph, now if V1 is given as 90 kmph. And if V2 is written as 60 kmph, 60, fine, it is given as 60. Yeah, Abhinav, it is 235 will be the final answer. 235 is the right answer. Fine. I'll explain a good concept to you. You'll get a good result from this. So just just have a look over here. Fine. So we'll see what will be the distance to avoid the head-on collision. So from velocity 1, we can calculate the SSD1 distance. SSD1 and SSD1 can be written as it is V1, or we can say it is 0.278 capital V multiplied by T plus capital V square divided by 254 multiplied by F. Fine. We'll put the values of velocity here, 0.278 multiplied by 90 multiplied by 2.5 plus capital V square, it is written as 90 square divided by 254 multiplied by 0.35. From here, you will get the value SSD1. You will get the value SSD1, and SSD1 value is 153.66, and SSD value is 153.66 meter. Fine. This is the way you can calculate the SSD1 value. Fine. Now if we calculate the SSD2 value, this value will be 0.278 capital V2 multiplied by T plus capital V2 square divided by 254 multiplied by F. Now what will happen? This can be written as 0.278 capital V. This capital V can be written as 60 multiplied by 2.5 plus capital V square is 60 square divided by 254 multiplied by F, and F value is written as 0.35. So the expression for the value for this expression is, the value for this SSD2 is 82.2. This SSD2 is 82.2 meter. So the final expression or final answer is SSD1 plus SSD2. So this can be written as 153.66 plus 82.2 meter plus 82.2 meter. So this can be written as 235.86 meter. Fine. This is the way you can calculate the answer over here. Fine. This is the way you can calculate the answer from basic approach. From basic approach, you will get the answer here. But I'll tell you something different, very much different from all this. I'll explain the reason behind why you can't calculate it by relative velocity concept. Let's see here why we can't calculate the particular question from relative velocity concept. So is this, I think this is clear for everyone. Whoever watching, is this clear to everyone, how we can calculate the particular formula, how we'll calculate the particular answer for this? Thank you, Afridi. Thank you so much. Is this clear? Fine. let's see why we are not using, relative velocity concept. Let's see why we are not using a relative velocity concept here. Let's see why we are not using relative velocity concept here. Let's see why we are not using relative velocity concept here, because it is one of the best question they'll ask in interview, why we are not using relative velocity concept. This is the one of the best question they'll ask if you are facing some bar interview or some good interview. You'll surely get this question, why we are not using the relative velocity concept here. So let's see here why we are not using the relative velocity concept here. So first I'll try to do it by relative velocity concept. Fine. Before this, I know that this SSD1, this the final distance, if somebody asks you, so it will be equal to SSD1 plus SSD2. Fine. So you can write it as, I'll give you the final expression if someday you want to calculate it directly. If someday you want to calculate it directly and you have a good memory, you can, if it is possible to memorize the particular formula, you can use that particular formula. Fine. So this is the way you can calculate the final value here. So let's see here, SSD1 plus SSD2, this can be written as, SSD1 is written as, you can say, if I'm just taking, okay fine. It is written as 0.278 capital V1 multiplied by T plus capital V1 square divided by 254 multiplied by F. Fine. This is your SSD1 plus, if somebody asks you about SSD2, so this value is written as 2.278 capital V multiplied by T plus capital V2 square. It is V2 square divided by 254 multiplied by F. Fine. If somebody asks, let's take some things common here. So it can be written as 0.278 T is taken common, so it can be written as V1 plus V2. It is written as V1 plus V2. And if they ask you to write it like combined form of this V1 and V2, you can say it can be written as 1 by 254F as common. This 1 by 254 is taken as common. 1 by 254 is taken common. And this can be written as, V1 square plus V2 square. This can be written as V1 square plus V2 square. So this is the final expression. If someday you want to directly use, you don't want to calculate SSD1 and SSD2, you can directly use this formula to get the answer. Like from this, you'll get the same answer, 235 or whatever you're getting. This is the same value, or this is the same formula from where you can get the final answer, correct answer. Fine. Now if we talk about the relative velocity concept, why we are not using relative velocity concept, let's talk about it. So okay, so this is the correct method. Or you can star mark it. You can directly use this formula to get the answer. Fine. Let's see here. Let's talk about the relative velocity concept and what is happening in relative velocity concept. What we'll do, just sit over the bonnet of this car. You'll sit on the bonnet of this car and see the vehicle that is coming from opposite direction. You'll think that the particular vehicle is in a stop position and the velocity of this vehicle is 150. What we are doing, it is 90 minus of 60. This is the relative velocity and it can be written as 150 kmph. This vehicle, you can see, you will think that particular vehicle is in a stop position and you are moving to that particular vehicle with a velocity of 150 kmph. Fine. So if somebody asks you to write the stopping side distance equation for this particular velocity, you can write it as, or we can say this value is V1, minus of V2. So the relative velocity is V1 plus V2. So if somebody asks you to write the stopping side distance equation for this relative velocity concept, you can write it as 0.278. Instead of V, we can write here V1 plus V2 because this is the combined velocity multiplied by time t. Fine. Plus, if somebody asks you to write, it is V1 plus V2 whole square divided by 254 multiplied by F. This is the expression you will get if you want to write the equation for with the help of relative velocity concept. This is the equation you will get. Fine. Now on comparing these two equation number 1 and equation number 2, on comparing these two equations, you will come to know that this part will never change. This part will never change. This is quite similar to this. हैंग हो गया. This is quite similar to, this is quite similar to this value. The first value is same as the first value for relative velocity concept. So we won't talk about this particular value. We won't talk about this particular value because it is similar in both the cases. Now I'll come to the second position. You'll see the 254F value is common. 254F value is common. Now what we'll see, the equation for for the particular correct method, you can use, you are using V1 square plus V2 square here, and you are using here V1 plus V2 ka whole square, V1 plus V2's whole square. So you can't write V1 square plus V2 square as V1 plus V2 whole square. Why we can't write it? Just take some random example that the velocity for V1 is 1 and the velocity for V2 is 2. So the expression, the final value from we are getting from here is 5 is equal to what we are doing here. It is 1 plus 2, that is 3. 3 square, this value is 9. So you never say that, you will never say that this value is equal. Your V1 square plus V2 square will never be equal to V1 plus V2 whole square. So this is the reason you can't use relative velocity concept, because in second expression we are using a quadratic equation, and two quadratic equation can't be merged simultaneously at the same time. Fine. So this is the reason why you can't use the relative velocity concept. This is the reason why. Fine. So this equation will give you wrong answer for the particular question. So is this clear to everyone? Like, this is the basic reason why we can't use the relative velocity concept, and I promise you most of the students don't know about it, and while facing the interview, if you give this answer, you'll surely get full marks. Fine. You'll get selected. I think the reason, the way you can express them, the way you'll get a better way to express them. Fine. So this is the reason, like, how you can come forward to others, like how can you beat other students in knowledge fight. Fine. So is this clear to everyone? Like, whatever we learned till now is I think you enjoyed the class, because I'm quite comfortable while teaching transportation, because it is one of my favorite subjects. So I just tried to teach, I just tried to tell you everything, whatever I know till now. So is this clear to everyone? Is everyone comfortable with this? What would be mentioned in question for relative velocity problem? Nothing is mentioned in relative velocity problem, but each and every student, the first thought that comes in student mind is, if some velocity, if some vehicle is coming from opposite direction, we just try to do it by relative velocity concept, and sometimes student get the, like if you are sitting in an exam hall, and if I didn't discuss the relative velocity concept to you, you will try to do it by relative velocity concept. You will think that some vehicle is coming from opposite direction. We'll take the final velocity as 150, and you'll solve the question. And you will find, I'm damn sure about it, out of 4 options, you'll get one option that is the result of relative velocity concept, and you'll tick mark that particular option. Fine. So this is the reason why I just want you to know that you can't use a relative velocity concept here to find the velocity to find the minimum distance, minimum safe distance between the two vehicles to avoid the head-on collision. Fine. So is this clear to everyone? Is this clear to everyone? Thank you so much, Manish. Thank you so much. I just have a one request to all of you guys. Just share this channel, because I just want, like, as I'm taking the lectures in Hindi on Gate Academy main channel and taking lectures in English on Gate Academy global channel. So I just want you to spread the Gate Academy global channel for those who are willing to learn the concept, and those who are not comfortable with Hindi. So I just want you to do this thing for me, because you are the only one who can distribute, who can spread this thing to a community, because I'm not a part of a community. I'm just a one who can help this community by some other mean. Fine. So thank you so much, everyone. Thank you for seeing me. Yeah, you all are you all enjoyed it, and I also enjoyed teaching you. Fine. So have a good day. Be safe, because the current situation is going to get worse. So just be safe, study hard. Now the next time you'll have we'll have some different concept over it. We'll have some different concept to talk about. And one more thing, start preparing in a good sense, in a dedicated way, because now the next situation, you don't know what will happen in the next situation. And what I can see is, like, you are going to face a tough competition whenever the things goes fine. You will face a tough competition in comparison to in comparison to any past 10 years, you will face the toughest competition in the upcoming examination. Fine. Thank you so much, everyone. Thank you so much. Study hard and keep yourself safe. Thank you so much.